Welcome, my dear aspirants, towards first PU syllabus in chemistry subject. The name of the chapter is States of Matter. During 2020-21 academic year, these topics were removed towards their portion, but as a whole, it is useful towards competitive point of view, NEET and JEE. Yes, let's take that those topics. First, we have to know the topics: kinetic energy and molecular speeds, liquefaction of gases, and purely liquid state to be taken. After that, in the second year, we will learn or we will discuss states of matter. Under states of matter, solid state. Yes, the first topic is kinetic energy and molecular speeds. Yes. How are molecules in gaseous state? They are very free to move, as these are the gaseous molecules. They are very free to move because the gap among the molecules are very more in gaseous state. Therefore, there is continuous motion is there, as these are moving in different directions. We studied as kinetic molecular theory of gases. Due to this, what will happen? As collisions among the molecules as well as on the walls of the container, and due to collisions on the walls of the container and continuous motion. What is next one? Continuous motion. Due to these two things, what will happen? The speed of the molecules are not uniform, and kinetic energy is also not uniform. Yes, what I given the information, due to continuous collisions and continuous motion and collisions among the molecules on the walls of the container, what will happen? The speed and kinetic energy of all the molecules at any instant, at any fraction of seconds are same or not same? Yes, answer is they are not same. So we want to know about different speeds possessed by different types of speeds possessed by gaseous molecules as well as kinetic energy. Here what is noticed? Kinetic energy is ever changing, but average kinetic energy where at a particular temperature. Why? Because temperature is fixed at a particular temperature. What happened at a particular temperature? Average kinetic energy is constant. This is very, very important point. Individual particles have different kinetic energy. They are changing among the molecules, but average kinetic energy is constant at a particular temperature is a key point. About these molecular speeds and kinetic energy, scientists Maxwell and Boltzmann gave a graphical representation towards distribution of velocities with a number of molecules. That graph is known as Maxwell Boltzmann distribution of molecular speeds. Okay, so let's take that graphical representation. Yes, on y-axis, number of molecules. In some books, fraction of molecules are given. Number of molecules taken on y-axis. X-axis, different molecular speeds are taken. Speeds on x-axis. Yes. At a particular temperature, how will be the graph? The graph is like this. Yes. As speed increase, number of molecules increase and reaches a maximum point and then decrease. Yes, like this. So from this graph, what we are going to draw some conclusions ready to draw from this graph. Yes, molecular speeds depend on what factors? Molecular speeds depend on which factors? One is temperature, depend on temperature. Second one is mass of the molecule, that is molecular mass. These are the two factors affecting the speed of the molecules. Yes, with a smaller speed, yes. Low speed, this is a low speed number of molecules. This is a high speed number of molecules. So number of molecules in these two cases, yes. What are the conclusions drawn from the graph, from the plot? Yes, what are the things? Yes, the point is molecules with least speed and highest speed. Yes, how are they? Least speed and highest speed. Number of molecules with the least speed and highest speed is less. Okay, then as there are a certain fraction of molecules possess some speed. Yes, this is the maximum number of molecules possessing a speed. As this particular speed is known as, observe the speed what I have marked as, this is very important. The velocity, this particular velocity or the speed possessed by how many number of molecules? Maximum number of molecules is known as maximum number of molecules is given by the special name is known as most probable velocity. Most probable velocity or most probable speed. Let us know about effect of temperature at two different temperatures. How will be the plots? Yes, this is number of or fraction of molecules versus speed. Yes, previously we took a graph, yes, like this. This is the peak of the graph. Over. Yes. Now this is happening at a T1 temperature. Now if you take a higher temperatures, conduct the same experiment at a higher temperatures, the graph will be like this. Yes, this is at T2 temperature. Relation between T1 and T2 is, T2 greater than T1 is one crucial point towards a competitive point of view. And how will be the graph? Yes, the peak of the graph as temperature increase, the peak of the graph is shifted to, this is a peak of the graph at velocity v1, and this is the peak of the graph at velocity v2. So at higher velocities means as temperature increase, velocity of the molecules increase. That is a fundamental point you learned. Yes, observe the peak of the graph is shifted towards higher velocities as temperature increase. Correct? As observe molecules with a higher speed. This is higher speed molecule, number of molecules with higher speed, some number. As here at the same speed, higher the number, higher the speed, how will be the number of the molecules? So the number of the molecules, number of molecules with a high speed is increased as temperature increases. At the same time, as with lower speed, the number of molecules are this one. and here the number of molecules. Yes, with a lower speed the number is decreased. One is decreased, another one is increased. This you have to identify from the graph. Observe how will be the peak of the graph. Yes, it becomes flattened. This graph becomes flattened and moves to higher velocity. Yes, that is a point to be taken. The curve is flattened. A graph is flattened. Curve is flattened means become broader. Yes, in the middle, and shifted towards which velocities? Higher velocities. So these are the conclusions from the graph. Yes, observe another point, that is temperature. Effect of temperature is explained. Second point is the size of the molecule, molar mass of the molecule. Yes, molecular mass. How does molecular mass also influence the speed of the molecule? Yes, affect the speed of the molecule. How? Speed of the molecule. As take a graphical representation in this case. Graphical representation. Yes, as usual. This is the graph related to chlorine. Yes, it is number of molecules or fraction of molecules on y-axis. Here it is, speed is taken. This is the maximum speed possessed by some number of chlorine molecules, and this maximum number of chlorine molecules possess this velocity is known as most probable velocity. Next one is nitrogen. As how is nitrogen? Yes, this is about nitrogen, and nitrogen most probable velocity is like this. Yes, so therefore the molecular speed, yes, most probable speed of what is most probable speed? This velocity possessed by maximum number of molecules known as most probable speed of nitrogen is greater than chlorine at a particular temperature. Both are at same temperature. Particular temperature. Okay. So this is. Now finally, what are the different velocities ready to possess by the molecules? One is why? Because they are ever changing due to collisions and continuous motion of the molecules. The speeds are not uniform. And how will be the speed? How do we calculate the speeds? Yes, different molecular speeds. Yes, the first one is average speed. Average speed is denoted by, yes, U is the speed, average, AV. How do we get average? As from mathematics. Yes, a molecule has U1 velocity, second one has U2 velocity, third one U3 velocity, and so on. All these velocities are added, and sum of the velocities divided by number of molecules n. So this is average speed to be calculated in this manner. Sometimes what will happen to average speed? Average speed means one molecule is moving in this direction, another molecule moving in this direction. It is 2 meters per second. It is also 2 meters per second. Then velocity is vector quantity, average velocity sometimes may become average velocity or average speed sometimes become tell me here, one direction plus 2, another direction minus 2, average velocity 0. But it is meaningless concept. Average velocity with 0 is not a proper way to describe the velocity of the molecule. Sometimes what will happen, suppose it is moving with 2 meter per second, it is with 4 meter per second, as it is in this direction, it is in this direction, and if it is minus, it is plus. Then what will happen, if you collect this data, it becomes negative. Average velocity negative is meaningless. So these are the drawbacks of average speed. How do we calculate average speed? Take one simple example and conclude the one. Yes, if you take speeds of 4 gaseous molecules at a particular temperature are 2, 6, 3 and 4 meter per second. Therefore, average velocity is equal to, that is equal to u1 plus u2 plus u3 plus u4 divided by total number of molecules 4. Therefore, 2 plus 6 plus 3 plus 4 by 4, 10, 15, 15 by 4 is the information. So this is the way of calculating average velocity. As to avoid getting negative or 0 average velocity, average speed, as what we are going to do, we are going to square the velocities of the molecules. So u1 becomes u1 square, u2 u2 square, and so on un square. We are squaring the velocities of all the molecules, and after squaring, do average. Mean is taken, a number of molecules, and after squaring, in order to get the original value, we have to do square root. This is known as URMS. This is second type of velocity. How do we take this velocity? Yes, it is the root mean square speed. As it gives more reliable information when compared to average velocity. So therefore, root mean square speed is given by URMS, and it is calculated by using above formula as. That much only we have to take. As these two are possible to take two individual molecules, but what is the third one? Yes, most probable velocity, most probable speed cannot be expressed expressed in terms of individual molecules. In terms of, why? Because observe this one, this is the velocity possessed by maximum number of molecules. So maximum number of molecules possess what is the speed? That is most probable speed. That is not for individual molecules. So not expressed in terms of individual molecules. Three different types of molecular speeds which depend on absolute temperature. with a formula. Yes, this is, and the formula to, yes, the formula to be used only for competitive point of view is to be collected like this. RMS velocity is equal to under root of 3 RT by m molar mass. Already we discussed about molar mass. Yes, this is 2 RT by molar mass under root of, and it is 8 RT by pi m under root. Yes, in all cases, how is the velocity or speed, molecular speed, depend on molar mass? Molecular mass inversely proportional to square root of molecular mass. The information we observed here. See this graph. Yes, chlorine has more molar mass than nitrogen at a particular temperature. So chlorine has less most probable velocity when compared to nitrogen. Why? Because heavier molecular mass moves slowly, and lightest molar mass, this is 28 and it is 71 gram per mole. So therefore it is move very fast when compared to chlorine. That information is provided in this formula, and the relation among these three to be taken. Yes, most probability RT by square root of RT by m is common, and therefore it is root 2 is to root 8 by pi is to root 3. After simplification, the final answer is 1 is to 1.128 is to 1.224. So which velocity is more? Which of the following velocity is more? RMS velocity is more than average velocity. Average velocity is more than most probable velocity. So this is the information possible to take from the graph very soon, very easily in the case. Yes, observe this one. This is most probable velocity, and this velocity is known as average velocity. Average velocity greater than most probable velocity, and it is RMS velocity. So this will be taken as a graph in this case. Yes, it is number of molecules, different speeds. Yes, this is the velocity possessed by maximum number of molecules, and it is known as most probable velocity. Yes, next one is, yes, this is most probable velocity. After that, this velocity is known as average velocity, and the last one is RMS velocity. Yes, and it is noticed from this one. That is end of different velocities and kinetic energy is the topic completed. Observe this problem, dear students. At 27 degrees centigrade, a gas containing different number of molecules with different speeds as given below. 1 meter per second 1 molecule, 2 meters per second 3 meters per second 5 molecules, 4 meter per second 6 molecules are traveling, 5 meter per second 7 molecules are traveling. So this is the maximum number of molecules possessing speed known as most probable velocity. As per theory, as what is this one? This is known as most probable velocity or most probable speed as per the definition. So answer is 5 meter per second is theoretical answer. Yes, with a 7 meter per second speed, the molecules are traveling. Number is 6, 8 meter per second 5 molecules, 9 meter per second. Yes, next 10 meter per second 1 molecule. So by following this data, as how do we calculate average velocity? Yes, come to average velocity. Very easy to calculate. Average velocity is equal to sum of the velocities. Some of the velocities are 1 plus, 2 plus, 3 plus, 4, 5, 7, 8, 9, 10 divided by total number of molecules. Here the total number of molecules are, the number is 37. Yes, after simplification, yes, here the mistake is only velocities are added with the number of molecules not multiplied, so this is wrong. Yes, take with one molecule with 1 meter per second, 3 molecules 2 meter per second. Next 4 molecules, 3 molecules 5 meter per second, 5 molecules 3 meter per second, 5 into 3 plus 6 into 4 plus 7 into 5 plus 6 into 7 plus 5 into 8 plus 3 into 9 plus 10 into 1 divided by, this is sum of the velocities of all molecules by total number of molecules, 37. The answer is yes, U, average velocity, is equal to how much? After totaling all these things, you got the value 200 divided 37, and you got the answer 5.4 meter per second. Now come to RMS velocity. U, RMS velocity, how do we take this one? Yes, it is the root of mean of square of velocities of all molecules. So first we are doing square of the velocities. Yes, so what are the squares of velocities? 1 square, 2 square, 3 square, 4 square, 5 square, 7 square, 8, 9, 10 squares into number of molecules. So by taking that one, yes, what is observed here? Square of velocities of all molecules into number of molecules, and the average is taken. The mean of square of velocities of all molecules is mean by 37 number of molecules. Yes, total number 37. Yes, after that, then after squaring we are going to do square root. Yes, this is the square root of this one. After simplification, you got the value 5.64 meter per second. Yes. So what is U, average velocity? Most probable velocity first, next average velocity, next RMS velocity. What is the conclusion we drawn? As per theory, it is 5. It is average velocity is here only taken 5.4, and RMS velocity is 5.64. Yes, if you recall the relation 1:1.128 is to 1.224. From this relation, if you calculate RMS velocity into most probable velocity, the relation is, so most probable velocity is equal to 0.8166 into RMS velocity is a relation from the previous formula. Then you got the value as after substituting 0.8166 into 5.64 is equal to 4.6, which is very close to 5. As this is theory and this is as per calculation. So that is the end of different types of velocities possessed by molecules.